Okay guys, so I have a problem that I turned my AC on and my coil was frozen and my blower motor was not turning on, and I suspect my blower motor has gone bad. The only reason I do that is because I have ice building up on the coil and not much I can do, and I'm not sure why it's doing that. So I took it apart and to look at my blower motor. It's just not turning on, and I can hear the gases passing through the thing. So I checked my compressor outside, the compressor was running and the blower motor is not, and obviously that's gonna freeze your system. So on this particular model, it's a ring unit, and it's a model RHL HM4821JA, and on this particular model it's just not it does not have a capacitor. So these have the efficiency ECM motors, and those basically don't have capacitor. On older units they do have capacitors that you can check, and in most cases the capacitors are bad, you just replace it and go your way. These are ECM X13 motors, and the way they're driven, they're basically getting a single phase and converting that to three phase. So the motor itself is a three-phase motor, and the module basically converts that single phase into three phase, and 90% of the time the module goes bad. They do have a kit that is available that you can connect to, and that kit is basically protects you if there is a power outage or a surge. The kit will get damaged itself, but it'll prevent your module from getting damaged. So I'm planning on getting that kit at a later time. But right now, for the task for me is to remove this whole thing, troubleshoot if it's truly the module is bad or if the motor is bad. The first thing you need to do to troubleshoot these kind of motor is you need to make sure your voltages are good. So this is the circuit board, and I'm going to take this apart so you guys can see that. First you need to make sure is your circuit board is good and is giving out what it needs to for the motor to run. So it's a very simple board. These connections right here, to make sure everything is plugged in, these are the three main connections that go to the motor. Your X1, which in my case is the common brown, and the brown goes into the common of the motor terminal. Then you have your two low voltage trigger. I call them trigger point because they're basically triggering when your AC comes on or your heat comes on. In my case, blue is the air conditioning trigger, the green one is the heat trigger, and that triggers the motor to turn on. So the way these motors work is they're always getting the 220 voltage supply. So here's my 220 volts coming in. You might have a 120, in my case it's a 220, and the 220 is constant power coming in. Two wires are going over there connecting to the main line, and the two are tapped in and going to the motor itself. So first thing you need to do is make sure you have 220 right at these terminals, and you can do that with a simple voltmeter. Connect it, make sure you have 220 with the breaker on, and once you have 220, the second thing you need to make sure is you have the trigger coming in, right? And the only way you get the trigger is when your thermostat is on. So turn your AC power to on and measure from common to the blue one and the common to the green one, whatever in your cases the trigger points are. And these two trigger points goes basically to the 1 through 5 tabs that you see on the motor. So 1 through 5 tabs, these are the speed tabs, and these motors are programmed by the manufacturer based on the type of motor you're getting. So you cannot just get any module and stick it in. You need to make sure it's programmed right, and if you have a motor that is programmed for all 5 these tabs, then it makes the life much more easier. In my case, all 5 are programmed, and the replacement that I'm going to get, I'll make sure all 5s are programmed. In my case, the 5th one and the first one is the one that I'm going to be using. 2, 3, and 4 I'm not going to be using. The one on the left hand side, there you go, now you can see that, is basically the N is the one leg of the 220, and the black one is the L, which is the other leg of 220. So now you have constant power. Then you have the middle one, which is the ground, which is just grounded to the case, and then the very last one that I have is the brown wire, which is the common of the trigger point. So now we know what all the wires do. So I have two trigger points right here, blue, green, and then I have a brown one, and then the two hot legs and a ground. And these are all the simple wiring for this particular one. And what I did was I checked the 220 coming in over here. My 220 was good. I turned on my thermostat and I checked my trigger point was there. So everything is good. So now something is definitely wrong with this, either the motor or the module. So now I'm gonna take this whole thing out, and the way you do it is you have the 4 screws on top, and I'm gonna unscrew them and slide it out. So let's do that next. So what you need to do is disconnect the connectors. I'm disconnecting this connector. I made a note of the color wires that were going over here. And now all the wires from the blower motor is off. Okay, so there were screws on top off right here. 4 screws that I showed you guys earlier, which is, so I removed it, and all I'm doing is sliding the motor out. Just make sure all the wires, everything is disconnected. I moved everything out of the way, so nothing is connected to the blower motor, and it's just a slide out. So let's go ahead and slide the blower motor out, and you can bring it down. There are hinges right here. This is your heater coil, and these are the hinges. Slide everything right up, and this is the motor that I need to get. Okay, so next thing is, don't just assume your blower motor is bad and you need to replace the entire motor. Since these motors don't have a capacitor in there, and you will not find any kind of capacitor in this particular one, what they have is a control module on the back of the actual motor. And what I did was, there are 2 long screws that are holding the module. All you need to do is just unscrew it. You don't need to tap or anything like that, just wiggle it out. You might have to pry it a little bit from the screwdriver gently and just remove it. Once you remove it, you will see a connector, and you will see this connector plugged into here. And I had removed mine before, so just showing you guys how I did it. So just remove the connector, and what you need to do at this point is put this away and check resistance on this. And you can take black one as a reference and then check the resistance what you have, and you should see a very low value. So I'll put my meter on the ohm low, and there you go. So 7 ohms, that's about right. And I'll check the other one, and 6.9. So that's fairly low. And what that tells me is the continuity from here to here or here to here. And another combination you can check is from here to here, and just move that in the center, and then just check it here. Oops. Sorry guys, it's kind of hard to work with one hand. And there you go. So that tells me that the continuity among all the coils, all the 3 wires, is very low impedance, which tells me that the bearing is good. The coil is good. And the way to check the bearing is just turn this, and if you see it freely moving, that tells you that the bearing is good. So there's nothing holding the motor. So this motor is good. There's nothing wrong with the motor. This thing has gone bad. So these control modules have capacitors and things like that, and these kind of can run you expensive, around $150 to $300 range, depending on what you buy. So these are the specs. You can search for X13 GENTEQ control module. So I'm gonna have to do my hunt and try to find this one. And once I have this one, all it is to plug and play, and everything should be good from there on. Okay, so I'll just replace the old one with the new one. Okay guys, so what I did was I replaced the module here. The way I did wire the connection was in and everything. It might be different, but the concept is pretty much the same. So this is the transformer which converts the voltage for the board 24 volt AC. So first you're going to make sure, if you're troubleshooting, is to make sure you have the 24 volt coming out of your transformer to the board. So you check it from the common to the 24 volt AC, and if you have 24 volt coming from the board, then you need to make sure when you're triggering an AC on, you should have 24 volt coming on one of these wires. So the top one, in my case, the brown one, is a common wire which goes to the C of this particular connector on the back of the motor. And then I have the two, which is the blue, in my case, is for the cold trigger, and the green, I believe this is for the heat trigger for the fan. So it's all the fan speeds depending on what you want, right? So in my case, these two are the wires, so for me to test it, what I did was I turned the AC on from inside with these wires removed, and I checked on these tabs, right, to make sure I have 24 volt AC. And the way you do it is you just reference common over here or on this guy here, and you just measure for 24 volt AC on one of these heat and cool tabs. So if you do have, as soon as you turn, make sure you turn the thermostat on. So if it's off, then you're not going to get the power. Remember, this control board gets the command and then sends the command to these terminals to turn the fan on. So I had that turned on inside the thermostat, and I checked, I did have 24 volt AC present, and now I'm connected to the motor. So now I know everything going to the motor is good. I have the, of course, I turned off the system, I turned the power off, and then I did my connections to make sure safety first. And I turned the breaker back on once I was fully connected. In my case, there is also a fuse here, so you make sure this fuse is not blown. Otherwise, if you're not getting 24 volt over here upon turning the thermostat on, then there might be something with the board. Now what I'm going to do is turn the AC on, and it should turn the system on. So one thing I did was, before I turned the AC on, I turned the compressor off, because I don't want the compressor to be kicked on or off if this thing doesn't work. So here's my Ecobee, and I'm gonna turn the cool on, and let's see if the system kicks on. Alright, and it seems like my fan came on. So that tells me that everything is working good. And now I'm just gonna clean up the clutter, put some tie wraps on, make sure they're not close to the fan area, and put everything nicely and make sure I cover this up, and turn the breaker on for the compressor, and my AC should be up and running. Thank you guys for watching. If it helps you in any way, please subscribe to my channel and like the video. Thank you.